The AI chip market is booming, and we are breaking it down, from Nvidia soaring dominance to the rise of custom ASICs, TPU compiler magic, power-hungry data centers, and the shift toward on-device intelligence. Two brothers, two perspectives, one question. Is this a revolution or just a temporary hype? Tune in and decide.
Welcome to the AI Brothers podcast. We are two brothers who have been discussing technology since we were kids and have decided to include you in these conversations.
We will cut through the noise to bring you data and research on the latest developments on AI. We are not interested in hype. We bring you the signal to keep you on top of this technical and industrial revolution.
Because AI will permeate everything and be everywhere, initially as a layer on top of existing system and then becoming itself the operating system.
Welcome back, everyone. Today we are diving into the rapidly growing AI chip market, GPU, ASICs, NPUs, etc. There's a whole universe of silicon behind the scenes, and right now Nvidia is riding at the center of the universe.
Or maybe just right in the center of the hype mania with the type of evaluation. Nvidia just hit $5 trillion in evaluation for what was supposed to be just a gaming company that recently shifted to AI.
Nvidia may have been initially focused on games, but those gaming GPUs were perfect for deep learning, parallel programming, thousands of small cores, matrix math. When AlexNet landed in 2012, researchers used Nvidia GPUs because they were ideal for neural networks. That set the whole industry in motion, you know?
And now you look at these servers, now you have server racks stuffed with 72 GPUs acting at one giant processor, $3 million rack, shipping 1,000 racks a week. Doesn't really make sense to me.
Is demand for training huge models and serving inference across thousands of apps, 6 million Blackwell GPUs shipped in a year. That scale is actually wild.
Well, that actually gets to the point where, we want to discuss today, which is that's why a lot of these hyperscalers, so these are companies who are building these data centers at scale, want to get off the Nvidia's leash. So you get a lot more of these custom ASIC. So you have Google, Amazon, Meta, Microsoft, OpenAI, Broadcom building half the stuff behind the scenes.
ASICs have their place, efficient and tuned. Google, for example, GPUs line kicked off in 2015, and they're already at generation 7. Those chips train models using XLA compiler stack, and that's where PyTorch XLA comes in. Google needed a way for PyTorch users to run code on TPUs, so they built a bridge that routes PyTorch operation through XLA. XLA compiles the operation into an optimized graphs, fuse kernels, schedule execution, and hits the TPU core at peak efficiency. You like PyTorch, but the compiler does the heavy lifting. They help TPU become a real alternative to Nvidia.
Well, I mean, you kind of like make it really simple and seamless, but it's not as magic as you're painting it. PyTorch XLA captures operation lazily, builds a graph behind the scene, and only execute when you force a step. It's basically PyTorch pretending to be a static graph framework. That alone shows how clunky, heterogeneous hardware is becoming.
Clunky or not, it enables CPU pods to train large models and at a huge scale. And the compilation pipeline matter. XLA does operation fusion, tiling, and layout optimization in way GPU do not always match. It's a different philosophy. Compile the entire step, then run the optimized block. That's why Google loves it, you know?
Yeah, but you conveniently skip the part where ASICs are inflexible. Once etched, they're stuck, which is fine until the AI landscape shifts 6 months later. GPUs survive because they're like a Swiss Army knife. ASICs are fixed.
True, but hyperscaler do not need flexibility the same way startups do. If you're Amazon shaving watts off inference, it saves them millions. That's why they invest in ASICs, not to beat Nvidia, but to actually control their costs, you know?
Well, I understand. It's just sort of within that framework of reducing the dependency. I get it. But because, NVIDIA's GPUs cost around $40,000. That's a lot of money. Even if you buy them, you need on top of that the power to run them. And data centers are hitting energy ceilings faster than compute ceilings. So I get the context.
And that's where on-device AI steps in also. NPUs inside phones, tablets, laptops. Apple's has its own has developed its own neural engine. Qualcomm and Samsung also. Local inference cut load off and boost privacy and keep latency extremely low. You know.
You just dump a ton of optimism. NPUs are nice, but edge devices are not going to solve the data center problems. Most AI still runs on the cloud.
Yeah, actually, for now, yeah, you can say that. But more and more AI is shifting to local compute. Cars, camera, robots, they're all gonna run locally. They run models directly. No round trips to data centers burning megawatts per request, you know?
Well, now that we're talking about this, we need to talk also about the FPGAs. Flexible, reconfigurable, they're slower, less efficient, but useful when companies want something between the general GPU and the rigid ASIC.
Yeah, actually, AMD certainly thinks so. They bought Xilinx for 49 billion. Intel still pushing Ultra, telecom, signal processing, smart NICs. They matter for those workloads, you know?
All these chips, all this innovation, and nearly all of it produced by one company, TSMC. It remains the single point of failure of the whole AI economy right now.
Actually, I think that the TSMC is not the only producer, and the AI chip supply chain is getting better. It's diversifying, you know.
Well, and the other problem is energy. Power consumption is still a huge bottleneck. Data centers are just running out of electricity, and countries are boosting their energy production like crazy, trying to get themselves an edge in this game.
Okay, Nvidia software stack, CUDA, and the developer ecosystem. That's not trivial. And the PyTorch XLA shows how much effort goes into supporting alternative hardware. It's not just chips, it's compilers, it's runtime, distribution strategies, memory logic, entire software ecosystem, you know?
That's ecosystem is actually, yes, NVIDIA's advantage, but it's also its vulnerability. Once hyperscalers fully matured their ASIC software stack and open frameworks like XLA and MLRI spread, NVIDIA's luck is going crack.
Maybe, but demand is so huge that everyone can succeed. Data centers, AI, edge AI, specialized AI, the market is actually really wild.
Or it's just going to overheat like crazy.
Or it may be just transformative, you know?
Well, I guess this is why we're here. One of us call it progress. The other says it's a runaway market with no power sockets left.
Yeah, either way, the chip race is accelerating GPUs, ASICs, NPUs, and FPGA, and the software stack underneath it, from CUDA to XLA to ROCm, are shaping the future, you know?
Well, until the electricity bill collapses the whole thing.
We may see that in another episode, you know?